So that's it for type inference. Next topic, type erasure. That's another of those topics, that I mentioned a few times. I try to give you the gist of it, but now we're going to look at it in a little bit more detail and more importantly summarize, everything we have said about the type erasure so far. So type erasure is the way of the Java compiler to generate bytecode which implements our generic types and generic method. That's it's a bad definition because there are different ways we could have done that. Okay, so it's one of the possible ways. That's the actual way that was chosen by the Java developers. What's more interesting is why did they choose that way? So there's like an idea here. Okay, the first idea is performance. So we chose to use type erasure because type erasure allows you to generate bytecode in which there is nothing about generic. There's no extra class that are automatically generated by the compiler. There's no overhead, okay? Or there's a little bit of overhead, but not that much. So the worst overhead we have with type erasure is we have to do some extra typecasting, to verify things at runtime. I'm going to cover that in detail in a few slides. But overall, yeah, we are very economical. The bytecode for a generic program is as lean as the bytecode for a Java program that does not use generics. So that's kind of a nice feature. One thing that is not mentioned in the slide, but I need to bring it up too, backward compatibility. Okay, and I think that was actually probably the dominant reason. Type erasure allows us to generate bytecode that has nothing to do with generics. Therefore, this bytecode is compatible with previous version of Java that didn't know about generics. And that's a big, big deal. Okay? So there's always, two sides and people are criticizing, etc. But you have to acknowledge, the benefit. Most situations are a trade-off. So if we do not have type erasure, it's true. We could do better and more interesting things at runtime with Java generics, notably metaprogramming. But at the same time, we would pay another cost for it. So it really depends what you want your language to be good at. So there's not a good and a bad solution. It's really, whether that solution is appropriate for the job that you have to do. So if you have ever to choose between Java and, for example, C# or something like that, these are the kind of things you want to look at. Okay, what are the main constraints on my project? And now if I choose this language, is this language making design decisions that are compatible with my constraints or not? So those 3 items here on the slides are a high-level summary of what it means to apply type erasure. Okay? So we are done compiling your code. Your code has generic method, generic classes in it. Now we're going to apply type erasure. So the first thing that type erasure means is I'm going to replace all the type parameters. So all of those, angular bracket T, etc. that you have used in your code, I'm going to replace them by object. So I'm going back, to the good old way of doing generic programming before Java had generics. I'm going to replace them by object, or if you were using a bounded type parameter, then instead I'm going to replace it by the bound that you specified. Okay? So if you said, angular bracket T extends A and B and C, then I'm going to take the leftmost, A. So remember, I told you the leftmost bound has a special meaning. If any of your bound is going to be a class, that has to be the leftmost one. That's a rule, okay? And I also mentioned that it was used in a special manner. This is how it's used. So if you say that you extend, that you subclass actually a class and then 2 interfaces, everywhere in your code, instances of that type parameter are going to be replaced by the leftmost bound.
So what about B and C?
B and C are not there.
Well, what if my code is depending on that?
So the question is, what happened to B and C? And my answer was, they are not there.
Yeah.
And then the remark, well, what if my code depends on that? So the answer is really bad. It's going to be all right. Okay, but you are going to see why it's going to be all right because of item 2 and 3. So type erasure is not going to leave you in a situation where if your code is mentioning somehow, B and C, you are going to have a problem. You're never possibly going to have a problem with type erasure. But for you to be convinced of that, I need to go over item 2 and 3. Okay, but you are right that if we were just removing the type, the parameter type information, then where is my information? And that's actually the price we pay in Java. To get efficiency, to get backward compatibility, we lose information, we lose almost every single bit of information we have about generic data type once we reach runtime. Okay, it's brutal. We technically do a type parameterectomy, I guess. We remove the type parameter from the code, and that's it. They are gone. All right. So, and you're going to see that this brings a lot of the limitation of generics, by the way.
Yeah,
Question?
You use bond not extends, but super, so it's will it be object at the end?
No. So the question is, what if I use bounded type parameter, but instead of using extends, I use super as a keyword? And that you cannot do. Forbidden. What you are thinking about is wildcards type parameter. Because when we are going to cover that, in the next section of that slideshow, but wildcards parameter are going to allow us to do, bounded data types where we can use either the keyword extend or super. But right now, I want you to remember, because that's a common source of error, when you talk about bounded type parameter, which is what we studied so far, okay, in the previous lecture, these guys always use only the keyword extend. So you can say angular bracket T extends employee. That's an appropriate bounded type parameter. But you can never write T super employee. That's not allowed actually in the Java language. Okay? You're going to see when we go through wildcards, you're going to see what is the benefit of super, but also what are the limitations that come with it. So maybe that will, cast things a little bit in.
Yeah, but in what sense we cannot use? Because I tried it with functional interfaces.
Mm-hmm.
It worked.
No. So the question was, well, what do you mean we can't? I can, because I used it for functional interfaces and it worked. But functional interfaces actually use wildcard generic type parameter. So it's not the same. Like the bounded type parameter are kind of the poor child compared to wildcard type parameter. Okay, they allow you to pretty much obtain polymorphism. Okay, with generic data type, but they only work in one direction. Again, when we get to wildcard type parameter, we'll compare, all of them. You're going to see exactly which tool is meant to do which job. Okay, but good question too. So we lose everything. That's item 1 on this slide, but we don't actually lose everything, or somehow it ends up working. Okay, it ends up being all right. So why? Because of item 2 and 3. Item 2, very important. When the Java compiler applies type erasure, it removes all those parameter data types, okay? But as it does so, it also ensures that it adds into your code typecast, okay? So typecast that you never wrote in your code are going to be automatically added by the compiler. And it's actually a funny thing to think about, because sometimes those typecasts are going to generate an error. So sometimes you get an error that makes generic compiler error message difficult to understand. Sometimes you get a compiler error message. You read it thoroughly, and it tells you you are casting this into that, and it's not working. And you look at your code, and you're going to think, I never did that cast. What are you doing to me? You're adding bugs and then you're reporting them to me. It's called job security, right? So no, this is not an evil plan, to drive you mad. It's just that when the type information was erased, Java made sure that you would use your constructs appropriately. So if you have a list of integer, okay, I'm going to remove that data type, that type parameter integer, but I'm going to make sure that every time you get something out of that list, and every time you put something into that list, okay, I'm going to make sure that there is a typecast there, so that at runtime, if you do a trick on me and you try to put an employee object in what you defined as a list of integer, I'm going to catch it. Okay? That's the point of doing those typecast at runtime. It's like, sure, I lose the information that your list is a list of integer, but before to erase it, I'm going to add a bunch of typecasts everywhere you use that list, so that you cannot insert something that's not an integer, and you cannot take out something that's not an integer. And now we are good. Okay? So that should answer your question. So yes, even if you depend on those over interfaces, etc., it's going to be handled by the compiler. Okay? Now, the third trick that we're going to look at as we look at type erasure is generating bridge methods. So I'm not going to try to explain that in 2 minutes because we really need the support of the slide and an example, okay? But in a nutshell, it's going to fix a problem that occurs with polymorphism. So when you erase type parameters, we are going to see an example where the code breaks because you are trying to use polymorphism and polymorphism doesn't work anymore. Then we are going to show you how the compiler automatically fixes that for you. But again, generating bridge method means that the compiler pretty much add new methods to your code that you didn't write. So you need to be aware of that. Our goal is not for you to become, engineer specialized in Java generics. No, my goal is just for you, when you get some error in some Java code, to understand that maybe, it's not due directly to your code, but it's due to the interaction with, for example, generic methods. Okay? So let's take a closer look. So we're going to take a concrete example to illustrate how all of this is working together. So we have a class node here, and node actually has a non-bounded type parameter. So we are back to basic, generic class example. So public class node of t, and I use t here to define the attributes, the field data, and then I say I have a private node of t next. So it's another field, private also, that refers to a node of t object, another object. So this could be a linked list, for example, okay? And then I have my constructor node, and my constructor node takes an element of type t, the data, which I assign to the corresponding attribute, and an argument of type node of t next, which I assign to the field attribute that has the same name, okay? So nothing really fancy there, and then I have an accessor for the data field. I ask get data, and it returns a value of data type t, which is whatever I stored in my field. Okay, so a constructor, an accessor, and two private fields. So that's my generic class. Type erasure comes in. Type erasure comes in, and I told you, if we have bounded types, we do this and this and that. But if we do not have bounded types, we just replace t by object. So this is actually what's going to get compiled. The compiler is going to do that replacement and then generate the bytecode from that. So we have pretty much lost everything that we knew about what t is. Okay. So what if we use a bounded type parameter? Okay, so syntax for bounded type parameter is angular bracket t extends something. So in this case, we have only one, okay, and we say it's a comparable of t. So the generic class comparable of t is provided also in the Java collection framework. That's something that allows you to make sure, it's an interface actually, it allows you to make sure that you are going to provide a compare to method in your objects, so that you can compare objects to one another, for example, if you want to sort them, okay? So the rest of the code is the same, so we're still trying to implement that sort of linked list, okay? Only thing that we said is, I can make a linked list, but I need to hold a data type that can be compared. So that means I'm thinking ahead about, maybe I want to sort my linked list or stuff like that. So that's all we changed here. Again, type erasure, that's what happens. So type erasure says I replace t by the leftmost bound. So that was comparable of t. Okay? Comparable of t is the generic data type. So that's going to be erased too. So I'm really losing everything. I'm back to saying, my data field is a comparable.
So it will not be recursive. So in comparable class, it will not be again comparable. Because comparable was declared in the node, like, could you return to the slide? Please?
Yeah, we can return to the previous slide. There we go.
It's like T extends comparable T.
Yeah.
T should be inside comparable should be also like extends comparable. So it's like a recursive call.
No, okay, the question is we have something recursive here because we say T extends comparable of T, so I'm going to replace T by its definition, which is T extend comparable of T. So, okay, I see how you are coming on this, you know, like the perspective you have, but it's not a recursive definition. What you are saying here, the way to read that is to say the class node takes a type parameter T. The type parameter T has to be a subtype of something that is a comparable of T. So if I pass integer as type argument for my generic class, so T is integer, then it has to extend comparable of integer. Now, what throws a wrench, what makes us think about recursion and stuff like that, is that we use the same letter, and indeed we use the same letter because we want those two things to correspond, right? But it's mostly due to the way that the class, the generic class comparable work. You just don't say, I want a comparable object. Okay, you just don't say I implement the class comparable. You say I implement the class comparable of and the data type that you want to make comparable. So to me, this is not, even to me, this is not intuitive, okay? The way that you write comparable of T, or even when, you remember when we did metaprogramming, we had class of something. We didn't say I just want you to return to me an object of class, okay? That would be a row type. Now, class is a generic class, so we say, I want you to return to me an object of class of integer. It's just a way to actually allow the recipient class to know the data type that you are going to manipulate. Okay? So it's kind of like a workaround here to make sure that the class, for example, know that you want a class object that represents an employee. So you pass employee as type parameter. Same thing goes on here, close to, okay? But yes, it's kind of a little, it's unintuitive, as to say the least, okay? But that has to do more with the collection framework and the classes that we have to use that we cannot change, okay? Now, after type erasure, those two instances of T disappear, so we are back to, you know, pre-generic time. That's really the ID. Type erasure generates code that is Java before generics were introduced, okay? Yeah?
What was the purpose of introducing generics?
Okay, so the question is, what is the purpose of reducing generics?
Introducing generics when the compiler is like taking out all the part and, you know.
So that's a good question. The question is, why did we bother spending like 2 sessions, you know, learning about generics? You fried half of my brain with all those rules, and now you're telling me Java doesn't care and trash everything I worked out. I'm going to kill the compiler. No, okay, don't go violent on me, right? There is a reason. Remember one thing about generics. When I started the lecture on generics, I told you generics are not allowing you to do something more, something new. Okay? Because we could do generic programming in Java before Java 8 or Java 7 even. Okay? I think actually generics were Java 5. Okay, whatever. We could do generic programming before. We used object. You want a list of objects? Sure, you can take anything. What was the problem with that? When you define a list of objects, okay, you allow anything in that list. Your list is not necessarily homogeneous. Homogeneous meaning it contains elements of the same data type. So with generics, we saw that when I say I want a list of integer, as opposed to saying, you know, my list is going to manipulate object reference, then a list of integer, now the compiler has information to make sure that every time you add an element and you remove an element, it's an integer. Every time I add an element or I remove an element from a list of integer after it has been type erased, what did I say like 10, 15 minutes ago? I said there was going to be a cast, right? So the fact that in the code you wrote, this is a very important point. I mean, this is a great question. The fact that in your code you wrote, I want a list of integer. Sure, that information disappears with type erasure. But before it disappears, the Java compiler is going to make sure that everywhere in your code where you add something to that list, or you take something out of that list, there is an automatic typecasting that is inserted, without you doing anything, to make sure that at runtime your code still detects that we add only integers to that list and we take away only integers from that list. So the job is done. You see what I'm saying? The fact that you said I want a list of integer add an effect on the code, even for the keyword integer, the type parameter itself was removed. But before to remove it, the compiler made sure to keep that in mind and modify your code. So whereas in a list, in a generic list, that just uses reference to object, you could add an integer, then a double, then take out a string, and nothing can be done to check that. With generics, yes, checks are going to be made for you. And that's actually one of the main difficulty that students have with generics. Everybody who learns about Java generics is going to bump into that question. Why am I doing this to myself, right? And you are because you want type safety. That's the answer. You don't want to be able to do fantastic things that you could not do before. No, you could do those things, but instead of having a workaround that is dangerous because no check can be made, now you have type safety. That's what generics in Java give you. Make sense? Question?
I have question, comment, or something like that. Because introducing generics now make it a little bit another kind of work. You need to consider use it or not. Can I use casts or can I use generics? And sometimes using generics could lead to having the generics going up to all classes in your library, and then you think it was easier to just use cast at several places, not just use generics everywhere.
Yeah.
So it's like another problem here. You should really consider use it or not to use it. So it's like in Java, I faced this problem in Java, but in other languages probably ways like type inferences is more developed, it's easier, and this problem is not so obvious.
So trying to summarize, okay, for the recording. Correct me if I misrepresent what you said, but the core of it was, well, we have a choice, right? We can use generics, or we can use good old, reference to object and do the cast ourselves. So why would I bother with generics that introduce all those potential problems? And they are hard to learn the first time around, generics, Java generics. So I totally agree with that. But the question is, why would I use that since I can use something else? Okay? So that's the second part of the answer to the previous question. The previous question was, you want tape safety. But then the follow-up question is, I can do tape safety. I know how to program. I can put those casts in myself. So now this is more of a philosophical argument, okay? So we are getting into subjective land. The difference here is a matter of personal preference. Do you want to be the one that's accountable for doing all of those casts? Okay? Or do you want the compiler to automatically insert the cast? If you want to rely on the compiler, then you need to talk to the compiler, give it more information. The language that you use to talk about that extra information is generics. Okay? So the generics are the best way in Java to allow the Java compiler to take the burden of doing those type conversion when they are necessary for you. But now, yes, it's a perfectly valid argument. You say, I have a small class to write. I have 2 places in my code where I need to do type conversion. Why generics? Okay, so you write your code, you do not use generics, you do your typecasting. Who is going to use your code? Somebody else is going to use your code, your list, etc. So there are people that are going to make mistakes, that are going to try to put into your list, they say, I want a list of, in their mind, they want a list of integer, but then they make mistake, they put a double. Okay? So then it's out of your control. You cannot guarantee that every single programmer in your company, or even in the world, if it's an open source project, is going to actually use your code correctly. Okay? So, yeah, go ahead.
Yeah, but if you create some code that is just for your library, inside your library, you can use just cast.
Yep. Absolutely. The remark is, but what if nobody else is using my code? What if I really have a piece of code that I write only for one use, for example, and I'm not going to work on it 6 months later. I'm never going to extend it, okay? And that code really needs only 2 typecasts. Do I go typecast or do I go generics? If it's only your code, it's your decision. Even better, if you know that this is throwaway code that you're going to use one time, for example, to extract data from a database and put it in another database, if you are sure that you are on top of your code, you know that you can control its complexity, then it's your decision again. Even more so, because the code will never be extended in the future. If you consider extending your code in the future, if you consider sharing it, if other people are going to use it, if your code grows complicated, these are the scenarios where having type safety from the compiler represents an advantage.
Yeah, but I'm saying that generics, introducing generics was actually provided. You need to make another decision, what you should do. So it's like another difficulty. It introduced another difficulty. At first it was just costs. It's like was no matter. You should control your code. And now you have choice, and it's like for programmers.
Okay.
Difficult.
So that's the part I didn't address in your original question. Yes, there was an aspect of your question that was, but because you put generics in Java, now we have a choice. So there is more work to do from the programmer perspective. We have to decide whether we want to use them or we want to use the typecasting.
Yeah,
correct?
Sometimes we do not know how a code will be used, and sometimes you make a decision.
Yep.
Okay, I will use generics, and then you have verbal syntax all around your library. So it's like that it was required just for several casts, and there is like you do not know. Generics or not.
So yeah, you don't know how your code is going to be used. That's the follow-up argument. So I don't know if I need actually generics or not. Okay, maybe in 6 months I'll change my mind and I want to expand this code. So if you have any doubt, use generics. That's actually the safe way. Okay, except if you know that your code is for you only and to throw away in 2 days, I would say use generics. Okay. Now the argument that says, well, but look what you did to us. Now we have to decide whether we want generics or not. It's an added complication for the programmer. We don't need more complication. We had a way to do things, right? We just had to be careful. It's kind of like saying, why did we invent planes? I had a car, I had a car and I could go to Tampa and I could go to Orlando and I could go to Michigan, I could go everywhere. But now you tell me, I have a choice. I can go to the other end of the United States by car. It's going to take me 3 days of driving, or I have to take a plane. How dare you do that to me? That's kind of how the argument goes, okay? I'm not sure the analogy is 100% fair, but I think it's still interesting, it's still funny. So yes, you have different ways, okay? You have different tools for different job. But that has always been our problem as programmer or even as IT professional, right? Somebody tells you, I want a web server. Well, you know of 5 different major web server. You can deploy them on 3 different platforms, okay? So which one do you use? Why so many choices? Sometimes you can reason that there is a benefit, okay? But I'll be honest, sometimes with our discipline in IT, like for example, if somebody tells you, I want a web application, I want a single page web application, and I want you to use JavaScript. And then you look around and you figure out that there is a list of JavaScript frameworks that goes on and goes on and goes on. And chances are that before you read the entire list, another one popped up somewhere and is becoming really popular. And everybody is saying, oh, if you're not using the latest version of this, you are like a noob, right? So, okay, so sometimes it's true. Sometimes in IT, in any technology-related field, you are going to have an avalanche of innovation, and it's overkill. Okay, because at the end of the day, we are kind of like in a Precambrian explosion of diversity, and then some of those solutions need to merge or disappear because we don't need that many solutions to a simple problem. I don't think Java generics fit in that category. I can see where you're coming from, okay, and it's true that sometimes what he's saying is right. We have too many choice, and this is actually an added burden. In this case, I would say you have to go with generics most of the time. The only case I would really recommend you avoid generics is, again, you are the only developer, the code is only for you or your own library, and you're not going to use that code later. You're not going to expand it. But if you think you might expand it, write it in a way that Java can check it. And again, that doesn't mean that you could not do the same job with Python, with a doc typing, language, with any of those sort of things. No, it's just that if you choose Java to start off with, that means that you opted from the get-go for a strongly typed language. So if you opt for a strongly typed language instead of going to something like more lightweight, like Python, that is more dynamic, okay? If you opt for a strongly typed language, but then you don't use it for what it's good at, then you're dealing with the cumbersome Java syntax all the time. But the one time where it could actually help you, prevent errors, you just didn't feel like going that extra mile with generics, and now Java is useless to you. Okay, you might as well use a dynamically typed language, and you would code faster, and you would be responsible for all of your checks, but you would get also that extra productivity. You see what I mean? No ceremony as in Java. All right. So very good questions. Anybody else has a remark, question on this? So far, so good. All right. So give me 1 minute to figure out where we were here. Okay, so yeah, that was an example on this slide that was actually featuring a bounded type parameter. So we replaced it by the leftmost bound that was specified, which was comparable. So that's what we get after type erasure here. Let's talk about generic methods. So these were examples of type erasure for generic types. Let's take a look at generic methods. So here's a method count, static method. Type parameter is t. Give me an element of type t, give me an array of elements of type t, and I'm going to tell you how many times that element occurs in the array. So I just count how many times the element was there. Okay? Type erasure on this guy, this is what it's going to look like. So array of t becomes an array of object. T becomes an object. We lose again all the information. Okay? T in this occurrence becomes an object as well, so we completely lost T. What this slide is not showing you, and what was the answer to your original question, was, okay, sure, we lose everything here in the definition of the method, but before to lose it, we looked at all of your code that was using that method. And every time you were using that method, if I needed to insert a runtime type conversion to make it work, to make sure it was safe, then I did it for you. Okay? Example, I don't think this example is going to add much actually. We have a shape, so we have a little inheritance, right? Circle extend shape, rectangle extend shape, so we have two subclasses of shape. And then we say here, here's the bounded type parameter, for that method, static method void draw. My type parameter is t extends shape, and the argument of the method itself is shape of type t. So what I want is you to give me a shape, or a rectangle, or a circle, okay? And type erasure makes it so that we replace t by the bound, so shape. And this is, I don't know if I'm anticipating your question, but just give me 1 second. And this is interesting because we just went from a bounded type parameter to what? To using just a superclass, okay? So remember the previous lecture where we took exactly that example? So in this case, is it really, to bounce on your question, is it really useful for us to use generics here? Not really. Okay? We have one parameter. We want to say, I want shapes or any of its subclasses. I don't have to use generics, and I don't have to use type bounded parameter here to make it work. I can use just polymorphism. Okay? You had a question?
Yeah. Suppose we don't know what numbers and numbers does not exist. Okay.
Okay.
That. And then I want to do t extends, suppose integer and double. And somewhere then I'm using double. So how will the compiler tackle that?
Okay, so let me summarize for the recording. You correct me if I misunderstand your question, okay? But the question is in the lines of, what if I have two classes, like integer and number? Double, sorry, I messed that up. Integer and double, okay? And I want to allow both of them to be actually parameters, but I don't have a class number in my system. So I don't have a superclass of both integer and double. Well, how can you do that? If you want to use polymorphism, object. Because even if two classes are completely unrelated in Java, they still inherit indirectly from the object superclass. So there is always a superclass that is common between any pair of classes in Java. The problem is that object is very, very generic, right? So you're going to run into all sorts of problems. You're going to do typecasting. It's really messy. If you want to use, bounded type parameters, you really can't. If assuming that integer and double are two classes, okay? Not interfaces, classes. If both of them are classes, the temptation would be to say T extends integer, comma, double. You can do that, right? With a bounded type parameter. You can specify several bounds, but only one of them can be a class. So in your specific question, you cannot do that. But if you add, for example, integer and comparable, and then there's no common superclass between the two, you could say T extend integer, which is a class, comma, comparable of integer, which is actually an interface. Or comparable of T, sorry. So yeah, your example is really difficult. In that case, if you don't have a superclass, you're going to have a problem with both the polymorphism approach at the bottom of the slide and the bounded type parameter approach that is right before it. Good example. Yeah, question?
Stupid question. I'm just getting confused between. So what's the difference between? So right now the method has a return type of void, and it has so it's like public static. Then you have the generic type T, which extends the class shape.
Okay.
Void cross. So in this case, the return type of the function is none.
Yeah. In that example, public static T extend shape void draw. The return type of the method is void, which means nothing. Yeah.
So the generic T extends shape is just adding a bound to it.
No, the type parameter notation T extend shape between angular brackets is not adding anything to the return type. Okay. What it's saying is, I have a public static void draw method. This method has a type parameter T that is bounded. It extends shape. So that's what it's saying. So it's telling you about the type parameter of the method, but it doesn't tell you anything about the return type of the method because it's void. However, the type parameter is used here to qualify the first parameter of the method itself. So this method draw takes one parameter named shape, and the data type of that parameter needs to be T. So you have a type parameter for your generic method. You use it for the argument, but you do not use it for the return value. Does that make sense?
So it wouldn't be a difference if I would have written angular brackets T extends shape after draw, right? After the method name.
Okay. So the question is, and this is where generics get like really annoying, but it's okay. This is a good question. The question is, what if I take angular brackets T extend shape, and instead of putting it between static and void, I put it between draw and the opening parenthesis. That is illegal syntax. That is illegal syntax because the type parameter needs to be specified before actually the return type of the method. However, the reason for which I say this is a good question is because what you might have in the back of your head that's bothering you right now is sometime you put those angular brackets before, sometime you put them after. When do I put them before? I put them before when I'm actually defining the generic method. Okay, or when I call the generic method, I put the angular brackets right before the name of the method, even after a dot. And then somewhere in the lecture, I've been putting those angular brackets after the name of constructors. Yes. So yes, sometimes I've been putting those angular brackets after the name of a quote-unquote method, but it was a very special method. It was a constructor, and the angular brackets allowed me to specify a type argument that was not for the constructor, for the class. So you guys are spoiling the fun because I had like a few slides at the end, just about that, but you already put your finger, exactly where it hurts. The question is, if I have a generic class, okay, this class is a constructor, the generic class is a constructor. So when I call the constructor, I need to use either diamond operator or specifies the type after the name of the constructor. Okay, but let's say that that constructor is also a generic constructor, like it would be a generic method, right? So it has another type parameter. Where do I specify this type parameter? Before the name of the constructor. So you can have like a situation where you are going to have, something. Let's say the name of my class is something s equal new angular bracket integer close the angular bracket something, the name of the constructor, angular bracket double, because that's the parameter for the class, close the angular bracket, open the parentheses, pass your argument. Yeah. And once you have seen that, that's what I wanted to finish this lecture with. You completely spoiled it. But once you have seen that, generally what you do is you vow to yourself to never touch Java generics again in your life, okay? And I don't blame you, but if you see that code coming at you from somebody else, or you are trying to understand somebody's code for whatever reason they use Java generics, I want you to be able to survive this. Okay, I don't want you necessarily to generate that kind of code, because that's really mean to other programmer, but I want you to at least be able to decipher it, and see what was the intent. Okay? So everybody expect a constructor, a generic constructor from a generic class to the next exam. Even if I try to be that mean, okay, you should all ace it. We talked about it. You have an opportunity to ask questions. The forums are there. We have a few weeks before the exam. Come talk to me during office hour. Come talk to the TA. Okay? We talked about it in class, and there are a few slides at the end that are going to summarize it for you. So that should not, even that horrible example, should not get you down. Okay? You see that in an exam, don't freak out. If you understand it now, you'll understand it also in 2 weeks. Okay? If you don't understand it now, you have 2 weeks to understand it. It's all good. You have time. Okay? All right. We have... It's a good timing. It's perfect timing. I was going to say we have about 10 minutes and somebody tries to already get in. So yes, we can do that, because this is actually a relatively simple concept. And it's not something that I'm going to ask you to write. Okay, but I want you again to understand what happens behind the scenes. So let's go for type erasure tech 2, which is going to be bridge function, sorry. I got trapped into my own pun. Okay, so we have the same node class, node of t. Okay, so I didn't change much except that there is a setter instead of a getter. And then more importantly, I have a mynode class that extends node of integer. Okay, so constructor and setter. And the setter here, okay, uses the setter from the superclass. So overriding, polymorphism, all that good stuff. And this is going to be the painful bit. Okay, we have 3 slides to go through here. So here's some code that say I want to create a new mynode with parameter 5. Sorry. So mynode is itself not a generic class; it just extends a generic class. And then I do what I should not do, which is I'm going to use a row type. So I say the node n, okay, is equal to mn, and then I call the setter with a string. And you remember my node was extending node of integer. So yeah, okay, things are not going too well so far. And then I try to extract that data that I set, that was a string. I try to extract it and put it back into an integer, because to start off with, it should have been an integer all along. So that code is awful, okay? Compiler is going to complain about that. But I'm just illustrating it as, I'm using it as an illustration of the worst case scenario here for those kind of things, okay? So type erasure. Type erasure is going to do 2 things for us. It's going to add those typecasting. And the idea that is summarized in those callouts here, in those pop-ups windows, is that every time you get something in or out of an element, whether it's a field, whether it's a return value of a method, whatever, it doesn't matter. But every time you get something out of an expression or put something into a container, and that container or expression had its type erased at some level, then we're going to make sure that the extra typecasting is there to ensure that you use it properly. So Java, the Java compiler generated those typecasting. And maybe these are not the ones that we would have written, but it generated them based on the definition of our class. So you see that we use our classes a little loosely here. We don't use them right. So Java takes the definition of the class, understand an intended meaning, put those typecast, okay? And then, well, if we didn't use it right, that's our problem. So what happened when I run this code? Well, here's a funny bit. When you call setData here, the interesting bit is that because you erased data type, remember, you removed everything that was T, you replaced it by object. So we are calling a method which in nature is setData of object. And it's executed on your myNode object, okay? myNode class inherited a setData of object from node after it was type erased. So the node class is a generic one. It had a setter that took an integer as parameter, type T, okay? But it got erased. So now the method looks like setData of object. That's a problem. You're going to see exactly why. Now, inside the setData of object class, we just assign our data field, with the string reference that you passed as argument. No problem. And then we use mn to access that object data field. We expect the result to be an integer, right? Because we have extended a node of integer. Well, that's not going to be what happened. We convert it into string, and then we try to assign something that was converted to a reference on string to an integer. And this is going to cause a class cast exception. Okay? So complicated and long story short, we use this code like brute, and Java is not happy about it. Okay. But what is even more interesting is the Java compiler is going to try to fix that for us. It's going to introduce what is called bridge methods. Okay? And you are going to see what the bridge methods are in the last slide and what they fix exactly. So this should be the slide where everything comes together. So these are our classes after type erasure. Okay? So instead of extend node of integer, we extend just node. Okay? Every time we refer to like integer, then it's going to be integer itself. Here, everything is set to object. No problem. That is the problem. The problem is that after type erasure, our superclass now features a setData of object. There is no setData of object method here. So you cannot tell me anymore that this setter overrides that setter. Okay? That setter works when you pass an integer. If you try to pass a string, this is not a good match. This is a setter that's going to be called on your object. And because it takes object as parameter, a string will go in. No problem. So we lost completely the ability to detect any misuse of our class. Java fixes that for us in a weird way. Well, a weird way, a good way, but I mean, it's just a new concept. It adds automatically to the class myNode a setter with this signature. A setter that takes an object data parameter. So that this one matches the one you are really trying to override. And what does it do? It just converts data to an integer so that it calls this one. So the overriding mechanism was broken, okay, because we lost type information. We just add a method that says, hold on, I know exactly what's going on here. You are going to try to pass me objects. Whenever you pass me an object, I cast it into an integer if I can, and then that will call the proper method overriding is back in town.